Hello students, welcome back again in this ROSE project. ROSE project is conducted by Ray Shikshan Sanstha Sadguru Gadge Maharaj College Karad. Myself, Mr. Umas KNP. I am here to teach you subject chemistry. My topic is topic number 4, that is chemical thermodynamics. In previous video lecture, we completed concept of enthalpy, then some numericals regarding maximum work and first law of thermodynamics. Now in this video lecture, that is lecture number 5, our first point is work done in chemical reaction. So the work done by the system at constant temperature and pressure is given by W is equal to minus PEX into delta V. This is the formula for pressure volume work in expansion. Suppose if external pressure is equal to internal pressure of the gas, then we have to replace PEX by P, that is internal pressure of the gas. So we get W is equal to minus P into delta V. Then delta V means change in the volume. So V2 minus V1. Then we can finalize it minus P into V2, that is minus PV2 minus plus P into V1, that is PV1. For an ideal gas equation, we already aware of that PV is equal to nRT is the ideal gas equation. But in case of initial state, means if initial volume of gas is the V1 and initial number of moles is N1, then PV1 is equal to N1RT. Then V2 it is the final volume of gas and N2 it is the final number of moles. So PV2 is equal to N2RT. At constant temperature and pressure, W is equal to minus N2RT plus N1RT. It means the value of PV1 is equal to N1RT. We have to replace here, and value of PV2 is equal to N2RT. We have to replace here. Then we get W is equal to minus sign remains as it is. Value of PV2 is equal to N2RT plus sign here. Value of PV1 is equal to N1RT. Then simplify this minus in bracket N2 minus N1 RT, it is a common. Then N2 minus N1 is the delta Ng, that is number of moles of gaseous product minus number of moles of gaseous reactant. So W is equal to minus delta Ng into RT. This is the work done in the chemical reaction. The above equation means this equation, the work done by the system in the chemical reaction. So this is our first point. Now the sign of work is depends on change in volume. There are the three cases. Number first, if N2 is greater than N1, means number of moles of gaseous product is greater than number of moles of gaseous reactant, then delta Ng is equal to positive and W is negative. So work done by the system. Condition number 2, if N1 is greater than N2, means number of moles of gaseous reactant is greater than number of moles of gaseous product, where delta Ng is equal to negative and W is equal to positive. And we already know that W is equal to positive when work is done on the system. Now, if N1 is equal to N2 and Ng is equal to 0, means number of moles of gaseous reactant is equal to number of moles of gaseous product. Means number of moles of reactant and number of moles of product are equal. It indicates that delta Ng is equal to 0 and W is equal to 0. Or no PV work done, means no pressure volume type of work done when Number of moles of reactant and product are equal. Now, our next point is enthalpies of physical transformation. Enthalpies of physical transformation. Number first, enthalpy of phase transition. Enthalpy of phase transition. Phase means we are already know there are three phases: solid, liquid, and gaseous. And transition means to conversion. To conversion. So conversion of phase. It is the exact meaning of this. Let us see the definition. Enthalpy change in transition of one phase of a substance converted into another phase transition at constant temperature and pressure without change in a chemical composition, called as enthalpy of phase transition. It means enthalpy changes when transition means conversion of one phase of substance, means a solid is converted into liquid or solid is converted into gas, like that. Substance converted into another phase transition means phase change at constant temperature and pressure without change in a chemical composition. Number first point is here enthalpy of fusion. Let us start with the definition. Enthalpy changes that occurs when one mole of solid is converted into liquid without change in the temperature at constant pressure. It means we have to convert one mole of solid into its liquid phase without change in temperature at constant pressure. The meaning of exactly meaning of fusion, fuse होणे म्हणजे वितळणे. So conversion of solid into liquid are observed here at constant temperature and pressure. So let us see the example. H2O we already know it is also exist in solid. So stoichiometric coefficient of H2 is 1, that is 1 mole. We have to take here 1 mole. 1 mole of solid is converted into 1 mole of liquid. And enthalpy of fusion having a value plus 6.01 kilojoule per mole at 0 degree Celsius. Then we have to shift or reverse the reaction, means 1 mole of liquid is converted into 1 mole of solid. 1 mole of liquid is converted into 1 mole of solid. The concept called as enthalpy of freezing. Enthalpy of freezing. It means the change of liquid phase is converted into solid phase. The enthalpy change is called as enthalpy of freezing. And the value of enthalpy of freezing is exactly opposite to enthalpy of fusion. Means here it shows positive 6.01 kilojoule per mole and here shows negative 6.01 kilojoule per mole at 0 degree Celsius. Number 2, enthalpy of vaporization. Enthalpy of vaporization. Let us see the definition. Enthalpy change accompanying the vaporization of 1 mole of liquid without changing its temperature at constant pressure. Means enthalpy change accompanying in the vaporization. Vaporization means liquid phase is converted into its vapor phase or gaseous phase. 1 mole of liquid phase is converted into its gaseous phase. That process or that enthalpy change is called as enthalpy of vaporization. For example, H2O, I am taking here 1 mole of water existing in liquid phase and 1 mole of gas. That is 1 mole of water existing in gaseous phase are formed. Liquid phase converted into gaseous phase. That enthalpy change is called as enthalpy of vaporization. Here enthalpy of vaporization is plus 40 kilojoule per mole at 100 degree Celsius. Means temperature at constant pressure without changing its temperature at constant pressure. Means temperature and pressure is the constant here. Now H2O liquid is converted into H2O gas. Enthalpy of vaporization is plus 40 kilojoule per mole, but here at constant temperature 25 degree Celsius. and here constant temperature is 100 degree Celsius. So enthalpy of vaporization is a clearly simple concept. 1 mole of liquid phase is converted into its gaseous phase without change in temperature and pressure. Means here we have to constant temperature at 25 degree and here we have to constant temperature of 100 degree Celsius. In other hand, consideration of vapor is accompanied with the release of heat. Consideration of vapor is accompanied with release of heat. Let us see, H2O gas is converted into H2O liquid, means we have to reverse this reaction. Gas is converted into liquid. This enthalpy change is called as enthalpy of condensation. Enthalpy of condensation, and having a value minus 40 kilojoule per mole at 100 degrees Celsius. Sign is definitely opposite because we have reversed the reaction. Now concept number 3 is enthalpy of sublimation. Enthalpy of sublimation. So we have already observed that. Let us see the camphor, kapur. If you heat the camphor, then you observe that it is directly converted into its vapor phase or gaseous phase. The term indicates as sublimation. Let us see the diagram. So representing here, enthalpy of sublimation means solid is converted into gas. The process called as sublimation, and best example is camphor. Now let us start the definition. Enthalpy change for conversion of 1 mole of solid directly in vapor phase at constant temperature and pressure. This concept called as enthalpy of sublimation. For example, H2O solid, we have to take 1 mole of H2 as a solid phase. Then H2O solid is directly converted into H2O gas. The concept called as enthalpy of sublimation, and having a value 51.08 kilojoule per mole at 0 degree Celsius. But if enthalpy of sublimation takes place in 2 steps, like you have used the term in mathematics, A which gives B, then B which gives C, ultimately A which gives C. So let us observe the diagram. If we hit the solid, then it is converted into liquid. That is, A here it is a solid and B here it is a liquid. The concept called as fusion. A to B, the concept called as fusion. Then liquid phase is converted into gaseous phase. Then B is converted into C. A to B and B to C. The concept called as vaporization. Okay, so ultimately A to B, B to C, ultimately fusion plus vaporization, A to C. The concept called as sublimation. So let us see the reaction. H2O solid is converted into H2O liquid. The concept called as enthalpy of fusion, and the value 6.01 kilojoule per mole. And second one is H2O liquid is converted into H2O gas. H2O liquid is converted into H2O gas. No, so the concept called as vaporization, enthalpy of vaporization, having a value 45.07 kilojoule per mole. So if we add this A to B, B to C, ultimately cancellation of B and B. So finally we get H2O solid and H2O gas. Means solid is converted into H2O gas. So value of sublimation 45.07 plus 6.01 is equal to 51.08 kilojoule per mole. If this reaction takes place in 2 steps, then value of sublimation is same here and here. So we can write it as enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. Enthalpy of fusion plus enthalpy of vaporization means enthalpy of sublimation. Now, next concept is enthalpy for atomic and molecular changes. Number first, enthalpy of ionization. It is the enthalpy change together the removal of an electron from 1 mole of gaseous atom removal of an electron from 1 mole of gaseous atom. Let us see the example. So sodium, it is exist in gaseous phase. It is converted into cation, that is Na plus ion, which is also exist in gaseous phase, plus 1 electron is liberated. So enthalpy of ionization is 494 kilojoule per moles. It means sodium atom having atomic number 11, having a configuration 281. So 1 electron is lost here. So ultimately I can say that amount of energy is required to remove the electron from valence shell, because a one electron is exist in the valence shell of sodium. So amount of energy is required to remove the electron from valence shell, the concept also called as enthalpy of ionization. In other hand, enthalpy change when one mole of gas phase atom of an element accept electron to form gaseous anion. For example, chlorine exists in gaseous phase. Atomic number of chlorine is 17. Configuration is 287. So sodium chlorine atom add 1 electron. It is converted into its anion, that is Cl minus ion, also exists in gaseous phase. The concept called as electron gain enthalpy, having a value minus 349 kilojoule per mole. Means ionization enthalpy and electron gain enthalpy are exactly opposite. Okay. Now next concept is enthalpy of atomization. Definition is enthalpy change in a process when dissociation of one mole of gaseous substance into gaseous atom is called as enthalpy of atomization. Means one mole of gaseous substance into its atom, called as enthalpy of atomization. For example, if you see Cl2 exists in gaseous form, it is converted, dissociation means break or conversion. Cl2, it is converted into its atoms, gaseous atom Cl plus Cl. Cl2, it is converted into gaseous atom Cl plus Cl, and enthalpy change in this process is called as enthalpy of atomization. Enthalpy of atomization having a value 242 kilojoule per mole. Another example is CH4. CH4, then it is converted into C gas plus 4H gas, and enthalpy of atomization is 1660 kilojoule per mole. This is the enthalpy of atomization. Now, third concept is enthalpy of solution. Enthalpy of solution. Definition is enthalpy change in a process when one mole of substance is dissolved in a specific amount of solvent. Enthalpy change in a process when one mole of substance is dissolved in specific amount of solvent, called as enthalpy of solution. For example, NaCl exists in solid phase. It is dissolved in aqueous, that is in water. So it is converted into NaCl aqueous, means sodium chloride is dissolved in water. It forms sodium chloride solution. So that enthalpy change in here reaction NaCl plus aqueous, enthalpy of solution is 4 kilojoule per mole. Now next concept is enthalpy of solution at infinite dilution. At infinite dilution. So enthalpy change when one mole of substance is dissolved in, the word is mostly important here, infinite amount of solvent. Infinite amount of solvent, that is generally we have to use water. One mole of, for example, one mole of NaCl is dissolved in infinite amount of water. Okay, that concept called as enthalpy of solution at infinite solution. If an ionic compound dissolves in a water in two steps, number first, ions are separated from the molecule. For example, MX as a salt like that NaCl, Na and Cl. Mx is a general representation of any salt. Mx exists in solid phase. It is converted into its cation M plus gaseous form plus X minus, that is anion, also exists in gaseous form. For this step is crystal lattice enthalpy. Delta LH is the positive. Means if we dissociate a 1 mole of crystalline solid into its gaseous ion, if we dissociate 1 mole of crystalline solid, any solid, into its gaseous ion, the concept is called as crystal lattice enthalpy. And for that crystal lattice enthalpy is the positive value. And number 2, ions are hydrated with the water molecule surrounding with them. Ions are hydrated with the water molecule surrounding with them. Means this ion is hydrated with water molecule, means surrounded by water molecule. The concept called as hydration. For example, M plus exists in gaseous phase here plus X amount of H2, which use M in bracket H2X plus here. X minus gaseous form plus YH2O, which use X H2O Y minus. For this step, enthalpy change is the negative, and this is called as enthalpy of hydration. Representation is here. So we have finally concluded that enthalpy of the solution is equal to lattice enthalpy, that is crystal lattice enthalpy, and hydration enthalpy. Okay, so this is the overall regarding enthalpy of solution. Hopefully we have understood this. Thank you.